You're looking at our solar system, a seemingly perfect balance of planets orbiting around an average-sized main sequence star, the Sun. But what if something disturbed that balance? What if one day a rogue planet entered our solar system? Would it collide with another planet? Would it change the orbits of the planets as we know them today? And what would happen to life on Earth? I'm Fizz, and using a simulator called Universe Sandbox, I'm going to see what could happen if a rogue planet entered our solar system. Now, for those of you who aren't familiar with what a rogue planet is, it's a planet, commonly a Jupiter-sized planet, that isn't orbiting a star, probably hurtling through space at a few hundred kilometers per second after being flung out of its orbit around its parent star. These types of things would happen typically in binary star systems where two stars are orbiting each other and a planet happens to be orbiting around them, and that causes the orbit to become very unstable and usually ends up ejecting any planets that are orbiting around those stars. Sometimes, actually, these stars themselves can become so unstable that they end up getting sent out into space. Now, you can see, entering the frame at the top, I already have a rogue planet that is entering the solar system as we speak. So this is basically a Jupiter-sized planet. I basically copied Jupiter and I put it outside of the solar system and kind of launched it in. And I also made the speed considerably less than a few hundred kilometers per second. I've got it traveling about 25 kilometers per second, just so that we can see the effect of what's going to happen as it comes in. Now you can see that as it's entering, you can see the projected motion, that it's curving around because of the sun's gravitational effect on it. So I'm just going to take the trails off for a sec, and I want to maybe make this in such a way. Actually, you know what? Let's look at the orbits. Now you can see that the orbits of the planets and various other objects that are going around the sun, it kind of makes it look a little bit messy. But what I wanted to show here is, if you look at, let's see, zoom out a little bit. If you look at Saturn, you can see that the rogue planet, as it comes around, it's going to be intersecting the orbits of Jupiter and Saturn as it goes by. It's going to be coming really close to the inner planets as well. So I guess the question is anything going to happen? Is the Earth going to be affected by this? Is anything going to be affected by this? There's been a lot of, I guess, theories as to what might happen. And of course, taking this with a grain of salt, this is of course just a simulator. It's a game, quote unquote, that you can get on Steam. It's a remarkable gravity simulator. You can accurately conjure up simulations that are pretty close to what we would think would happen. So there's a lot of I guess unknowns or things that are not included in here, but it's a pretty good representation of what we would think. So as we kind of watch things play out here, I'm gonna increase the speed to, let's say, 0.5 months per second, just so we can kind of speed things along a little bit. And you'll see now as we go, we're kind of just kind of passed through the orbit of Mars a little bit, and now entering the outer regions of the solar system once again. So far things don't look to be too terrible. What will be interesting is when it passes by Saturn, because it looks like it's gonna pass pretty close to Saturn, a little bit below the orbit of Saturn, but fairly close, I would say. And there we go. Now we are kind of clear of everything that we would think would cause any major problems. It's gonna, I don't think it's gonna do anything to Uranus here, but for our purposes, let's go back. Let's assume that the danger is over now, any potential danger, and let's look at what's going on in the middle here, focusing on the sun. You can see that the sun actually has been affected. You can see that there's a slight trail now. So the sun has been actually affected by this rogue planet passing through, which is interesting for longer term outlooks as to what might happen. But everything else seems to be not really affected that much. Like, let's take a look at Earth here. All of Earth's vitals seem to be okay. The average surface temperature is right around where it should be. The distance to the sun is still right around where it should be. It fluctuates between 147 kilometers, 147 million kilometers to just over 150 million kilometers, which is around 1 astronomical unit, which is the distance as measured from the Earth to the sun. So if we increase this to, let's say, 1 year per second, you can see that things aren't really changing all that much for the Earth anyway. We're still kind of hovering around that average surface temperature. We're still, fluctuating between the usual distances. So the impact that this rogue planet has had has been minimal at best. I mean, except for the the pull that seems to have happened to the sun. So from our perspective, nothing would really change. Now let's pause for a second and think about what would happen if that object, that rogue planet, were replaced with a rogue star. Now remember, I mentioned that it's possible that a rogue star could be traveling, just past our solar system. In fact, it happened, I believe, 70,000 years ago. A rogue star did pass by the solar system. Now it was a lot farther out. It didn't pass through the solar system. It passed outside of the known reaches of the solar system. And I mean, we don't know if it had any effect at all. It probably didn't. But I mean, what would happen in the case that a star passed through the the orbits of the planets? Basically, is what we want to know. So I'm going to reload this simulation, and I'm going to replace this rogue planet with a rogue star. So how we do that is we go down here, we go to replace, we go to stars. Now I want a small star. I don't want a large star, because I mean, obviously a larger star is going to cause some major problems. Let's go with this one, Wolf 359. It's got a mass of about 94.3 Jupiters. Now if we put this in here and we go to suns, you can see that it's 0.09 times the mass of the sun. That's, compared to our sun, that's pretty small. So let's leave it there. Let's reduce our, we got it here at 1 month per second. That's going to be too fast. So let's go, initially, let's just go to 1 day per second. Let's, just to kind of get things started. Just so we can see, if anything immediate happens as this rogue star starts entering into the solar system. It's now like starting to enter in around about Jupiter's orbit. Jupiter is on the opposite side right now, so it wouldn't really do anything, but it is most likely already starting to affect the sun in a way. Yeah, you can see it right there. It's already affecting the sun. Now remember, this is 0.09 times the mass of the sun. So although that Jupiter-sized rogue planet started affecting the sun as it came closer to the sun, this is already starting to affect things, you know, that far out. Is it affecting the Earth in any way? Well, let's see. So far it looks okay. Nothing has really changed, but if you look at the orbit of the Earth, the orbit is starting to change already, the projected orbit. So it's actually starting to come in closer to the sun. So things are already in motion here as this rogue star starts to enter closer into the solar system's depths. So now let's speed things up a bit. Let's go 15 days per second. Let's keep an eye on what's going on with the Earth here. And the sun. Things are gonna probably get pretty crazy right about now. So let's pause right there. That is like, that's pretty close to, you know, affecting things. So far it still doesn't look like anything has really changed in terms of the Earth anyway. But if we keep running things, you'll see. Now look at what happens. Look at what happened to the Earth. Look at the orbit. We are now a lot closer. The temperature has gone up. The average surface temperature has gone up considerably, and that's not good. That is not good. Let's lower this back down to 1 day per second, and let's keep running. So the orbit, you can see the orbits have changed drastically already, and look at what's happening here. There is a solar system object, Vesta. Okay, it just completely looped around the star, the rogue star, and is no longer orbiting the sun. It's getting ejected out into space, basically. So an immediate effect right there. And the sun is now, you know, starting to accelerate off into a different direction. The Earth has wow, Venus and the Earth's orbits have intersected each other. So that's another interesting thing. What's going on with the Earth now? 31 degrees, that is uncomfortable. 31 degrees Celsius as the average surface temperature. That is 90 degrees Fahrenheit. So, I mean, that's pretty crazy. I guess the surface of the Earth is definitely changing because of this. Now, the orbit is not as, you know, close to what it was at all compared to what we would normally expect. So here you can see we're still not as far out as what a normal what one astronomical unit would be. Let's see where we are here. Here we go. Yeah, 0.9 astronomical units. So we're still closer to the sun than what we would normally want to be. Let's increase this again. Let's go 10 days. There. Look at the orbits. Crazy. .5 astronomical units. Look at the temperature. 47 degrees Celsius. 116 degrees Fahrenheit. Life on Earth can't. It wouldn't, under normal circumstances, be able to survive this, I don't think. So there you have it. A rogue star, which is still, it still hasn't passed the orbit of Saturn. Look at, it's probably gonna, whoa, all right, whoa. Look at what it did to Saturn. Wow. That's crazy. Saturn is now being greatly influenced by passing through of this rogue star, and Saturn is now going to head off into space. Bye bye, Saturn. We'll miss you. Now let's speed things up. Let's go back over here. Let's go months per second again. Now don't worry about the date here. I obviously had run the simulation before I started recording in its normal speed. I mean, sorry, not its normal speed. In like at a sped up pace. But let's see if we increase this now to 1 month per second again. Let's go 2 months per second actually, and let's zoom in. So as the sun moves in a different direction than what it would normally, the path that it would normally be taking around the galaxy, all the orbits have been affected by it. Now the inner planets, mostly everything is still orbiting the sun, except for that one object that got flung out. Saturn is gone. Let's see the actual orbits. Actually, no, Saturn's... is it? Where's Saturn? Yeah, Saturn's gone. That's the line of Saturn right there. Jupiter's still fine, but Jupiter has a crazy orbit now compared to what it's used to. So it's still got held in, which is nice, I guess. So yeah, there you go. Crazy stuff. Let's take orbits off, put trails back on, and let's go visit our good friend the Earth. Let's see. Not looking so good for our friend the Earth here. Looks like the poles have melted, seemingly. I mean, obviously. That's a no-brainer. There's some other stuff you can look at here. Surface temperature. So the average temperature. The maximum temperature is 101 degrees Celsius. The minimum temperature is 44.7 degrees Celsius. The average surface temperature is 82.5 degrees Celsius. That's nuts. You can also look at the habitable zone. This is the area around the Earth, also known as the Goldilocks zone, where life can exist, basically, for a planet. This is that green zone right here. Whoa, can't focus on anything. Let's go into the sun here. The Earth is not even spending any time in that habitable zone anymore. Mars is spending some time in that habitable zone. Interestingly enough, the average surface temperature of Mars is now fluctuating between -9 degrees Celsius and -16, 17 degrees Celsius. So that's interesting. But for all intents and purposes, the Earth is no longer a habitable planet. So there you go. That's what would happen. I hope you guys enjoyed this video. If you want to see any other types of simulations, let me know. I'd be happy to try them out. A lot of people use this program to simulate fun, crazy things like smashing stars together and peppering the Earth with, collisions from 30 Earth-sized moons, that kind of stuff. I've done that before. It's pretty fun. But I also wanted to see what would happen in this case if, hypothetically speaking, this situation played itself out. And I mean, don't worry, things are for something like for something like this to happen. The chances of something like this happening are it's extremely rare. So, you know, in our lifetime, in millions of years of the Earth's existence, something like this is very unlikely to happen. But it's fun to wonder what would happen if it did. Thanks for watching. We'll see you next time.